about basic operations of different measuring instruments. Okay, so then how it will work. Okay, so today I'll discuss about different classifications of measuring instrument. Okay, so before starting the classifications, okay, so we need to know the basic operations of the of our basic instruments that we have used in our lab. So finally you can if you listen my previous lecture, so you can understand that how it is operating in for measuring different electrical quantities like voltage, current, sometimes some other derived quantities like your like power, energy. Okay, so based on that process, so we can classify its option, classify the instrument in majorly you can say like that five or six types of their operation. Based on their operation, we can classify this six big group or six clusters. Okay. So first we know about it. In normally case one, it is known that absolute or the secondary instrument. Okay. So what do you mean by that absolute instrument? So absolute instrument is normally most of the time used for the standard laboratories, or you can say like that. I already discussed about the basic standard. What are the different types of standards? Is it in international standard or primary standard or the secondary standard? Sometimes is it for working standard? Then sometimes for the resistance, capacitance, inductance standard as per our measurement of the resistance, capacitance and the inductance. So how absolute your instrument is it? Normally we are using it for the standard laboratories. Okay. You can take some example like for the basic deflection we are using the tangent galvanometer. Okay, so any kinds of any operation, so we can operate it. Okay, so where we can detect the deflections, how much deflection is there, and by using that tangent galvanometer. Okay, so again we can go for the secondary instrument. So you can say like that absolute instrument means it will give you the accurate response. It will give you the accurate result at any cost. So in case of secondary instrument, when we are going for design any kinds of secondary instruments, so we have to find out some of the standard. Okay, so which kind of standard we are going to consider? Normally we are consider that absolute instrument as a standard instrument. Okay, so if we are using that absolute instrument as a standard, so we can design any of the secondary instrument. So normally it is again segregated, or it is differentiated in three types. Okay, so first one is called indicating instrument. Okay, so second one is integrating instrument, and third one is a recording instruments. So what is indicating instrument? Normally in ordinary ammeter, voltmeter, wattmeter, frequency meter. Okay, so you can say like that, if you connect the instrument in your circuit, so if any kinds of changes of the voltage and current, maybe power, maybe so the deflecting, the pointer of that instrument is deflecting its positions, means it is pointing out it is pointing out the actual value that you are going to be measured. So you can say like that it is indicating instrument because the pointer is indicating some of the value within the range of the scale. Okay, or the range of the measuring instrument. So it's normally globally known as indicating instrument. So after that you can say like that integrating instrument. What do you mean by that integrating instrument? Integrating instrument means it's related to the time. Okay, so integration, the standard indicating instrument is integrated with some time. So you can say like that is an example of the energy meter. Okay, in energy meter you can say like that it is ampere hour meter, or it is power indicating, means in energy power is integrating with the time. So you can say like that is an example of energy. So in case of energy meter you can say like that it is va T, maybe like that, that means volt ampere hour meter. Okay, so normally what happen? KVA normally we are using in energy meter in our domestic applications, means our distribution in our household applications. So where we are calculating the voltage and the current, as well as you are also calculating the time. Okay, so how much voltage is there, how much current is there, for which duration. So you are able to integrate the time with your other quantities, maybe voltage and current. So it is an example of integrating instrument. So next one is what? It is recording instrument. So in recording instrument, you are going to record the electrical quantities for individual instant. Okay, like you can say like that, for individual instant you are recording the voltage and current. Then what happens if you have some recording device, so you are collecting or fetching the data for individual instant. After getting all those data, at the time of calculation, you may use all those previous data to calculate or to predict. Okay, to predict the future analysis. Maybe I am just taking some example. Okay, if you going to visit any of the, if you going to visit any of the substation, so where you are able to see that different recording devices are there. So what is your demand, what is your present demand? Okay, so how much megawatt demand is right now, and it is calculating all the time. It is taking the value, means active power. Okay, after getting the active power, what is the actual demand, what is total generation. Okay, so you can easily calculate the reactive power as well as the power factor. So all the time, all the instant, it is calculating, it is recording the data, as well as is also calculating the associated data, associated quantities related to the associated data. Okay, so that means if you have the rating of the active power, if you have the rating, if you are able to fetch the data of active power, total generation, total demand. Okay, so you can easily calculate the other parameters like reactive power as well as the power factor. Okay, so another cases in plant, you can also using the synchroscope. So how much synchronizations is there, you can also calculate it. Mean generations quantity, that means electrical generations is there. So the generating frequency as well as the demand frequency, how much synchronizations is there. Okay, you can also calculate it. So how is it possible? By recording the instrument, by using recording type instrument. So what is the benefits of these kinds of instrument? Presently you are fetching the data. Okay, you are also calculating the all the parameters by using this data. But in future what happened, by previous data you can also predict. Okay, so you can say like that in last summer. Okay, in last summer any of the power plant you are getting, you may visit over there and you are getting all those previous year data. Okay, so in this coming year, so you can also calculate that, you can also predict. Okay, how much data may be coming, how much voltage demand is required at this summer session or as this festive season. Okay, such like that. If you are able to get all this previous 5 years, 6 years data, so you are able to predict some average. You can predict some average uses of the utility grid, your average uses of the utility demand. Okay, so like that. Okay, so you can easily getting, or you are easily predicting such type of things. So what you can say like that, a curve is traced which shows the variations in the magnitude to the electrical quantity under observation over a defined period of time. Okay, in case of recording instrument, such instruments are generally used in powerhouses where the current, voltage, power, etc. are to be maintained within the certain acceptable limit. Okay, so you are getting the idea. After getting all those data, you are predicting what happened in future, as per your measuring instrument. You can also install such type of instrument to getting all those data. Then we can go for the another most important thing, that is analog and digital instrument. Okay, so very simple. In analog instrument, what happened, in you are using that analog devices, maybe the pointer is there, then the scales are there. Okay, if the scales are there, means definitely the is it uniformly scaled or it is non-uniformly scaled, and if the pointer is there, definitely all the analog devices or mechanical devices you are using in the analog instrument. So the signal of the analog instrument unit vary in a continuous fashion and can take on the infinite number of the values in a given range. Okay, so definitely you are able to get definitely you are able to get different type of analog units over there, like such kinds of thing we are using, like fuel gauge, then ammeter, voltmeter, then watch. That means you can say like that speedometer. Sometimes we are using that in our lab, that is rpm meter, means it's a tacho generator. Okay, so such kinds of things all are that analog instrument. Now tacho generator is present, it's also available in digital mode also, but analog also it is available. Okay, so now we can go for what? Digital instrument. Okay, so digital instrument means what happened, that all the marking and everything, that means signal will be detected, and it will be measured in the digital manner, means there is a digital meter plate will be there, so where you are able to see the discretized value. Okay, where you are able to see that the digitalized value of the analog signals. Okay, like that you can say like the signal vary in discrete steps. Okay, and taking in a finite number of different values in a given range. In my last class I discussed about some zero order hold. Okay, so discrete step means when you are converting the digital signal to analog signal, definitely there is some actually what happens when you are converting that analog signal to digital signal, you are using some sampler switch. Okay, that switch is responsible for what? Sampling the analog signals. Okay, so if you discretize all those things, definitely what happens, when you are going to fetch the value, you are easily calculated and processing all those value, and it will be displayed to your uh, corresponding instrument. Okay, so that is in digital type. Okay, if you want to convert the digital signal again analog signal, you need to reconstruct all those digital signal to the analog signal. So in that case, you have to use different circuit. One of the example of the circuit is zero order hold. Okay, so in digital instrument have some advantages over the analog meter. So what type of advantages are there? So first one is that it is giving you the accurate results with high speed of operation. These two things are very important. Accurate result means what? How much maximum value you can extract from the system. That is your accurate results. Okay, so if you are able to extract maximum amount of value, then the error will be minimum. Okay, so that is one of your benefit. Though then another option is high speed operation. So how fast the operation is going on. Okay, if the operation is going on very fast, then what happens? So there is no such delay for measuring of your electrical quantity. If any kinds of delays is there for online measurement, so what happens? If any kinds of transportation delay, any kinds of other kinds of delays are there due to aging effect, due to heating effect, then what happens? You are not getting the exact value at exact instant, because digital instruments are very accurate. Okay, so you have to get the value in individual instant, because you are using some sampling fixed switches. Okay, so that is responsible for getting all such kinds of values. Okay, so unnecessary delays are not required in digital instrument. So it is giving you the high speed operation. So that is another beneficial thing, that is high accuracy and high speed operation. Okay, so it eliminates the human operational errors. So today I also discuss about some of the error signals. Okay, so where you can understand that what are the different types of error may be there. Okay, that will be discussed in my later slide, so you can easily understand from those slides. So human error should not be there. What happens if you are going to measure some of the value? If it is analog instrument, then you have to totally depends upon your own eye. Okay, if minimal number of variations is observed over there, so it will not be calculated, because if the changes is there one by, you know about that frequency, that which portion, which values you are able to see. Okay, so the changes should be there. Okay, so how much value, how much the frequency is observable by your eyes, that is also important. If that variation is beyond this range, so you are not able to fetch all those value. So in that case, the analog meter will not give you that accurate value. So you have to go for the digital instrument. So that's the basic advantages over the analog instrument by the digital instrument. Next one is, next segregation type is called mechanical, electrical and electronics instrument. So you say like that, the mechanical procedures, that means the instrument is normally designed by the mechanical procedures. Okay, so that are the example of the mechanical instruments, like your normal PMMC, means permanent magnet moving coil instrument, normal MI, that is your moving iron type instrument. All kinds of devices, analog devices, are based on the mechanical features of the instruments, or the mechanical features of the different parts of the instruments. Okay, so what happened due to aging effect? Definitely there is some problem. Okay, because longevity of the mechanical devices definitely poor compared to your electrical and the electronic instrument. Because what happened mechanically, if you are going to measure anything, definitely there is some problem of there is some problem of all the cases, maybe aging effect, maybe moisture effect, because metals you are going to be used. So there is some problem regarding that moisture is there, definitely some issues will be arrived. Okay, so there is some advantages as well as some disadvantages is there in the mechanical instrument. Okay, so again I will discuss that what are the advantages and what are the disadvantages, because mechanical devices are very cheap. Okay, so if you are going to establish very cheap laboratory, means cost efficient laboratory, so you can install some mechanical instrument. But if you are going to establish some nuclear power plant, in that case definitely you have to depends upon very sophisticated instrument, so that is not possible by the mechanical instrument. So you have to depends upon some electrical as well as some electronics instruments. Okay, so manual and automatic instrument, next feature. So manual means what happened, and automatic. Manual means you are manually operate all those things. Okay, so if you are able to see that the range you are going to measure that value, so what happened, you are using some trial and error method. Okay, you don't know the actual value of the voltage. Okay, so first what happened, you are incorporated. So if you don't know the actual range of the voltage, you can take one example. In your laboratory you have different types of voltmeter. It is in DC voltmeter, I am taking example, just like a DC voltmeter, the circuit is related to your DC. Okay, so first you don't know that what happened, the unknown measuring quantity or unknown voltage you have to going to measure. So what happened, so you have to use which type of voltmeter, definitely you have to use higher rated voltmeter, definitely. Okay, you don't know the actual values of the voltage rating, so you have 600 volt range of voltmeter. So directly you are connecting that voltmeter to your circuit, then you are able to measure that value. So you just see that your voltage is coming below 300 volt. So then what happens, you need to change it again. So you just dismantle that previous voltmeter and you are connected that 300 range of voltmeter, then you are able to measure that value. Maybe that result is coming below 100. So what happened, first you just you don't know about that range of that value, unknown value was that previously. So you are adding one directly 100 150 volt range voltmeter, and you are going to measure that maybe 160 volts. So what happened, you can able to see that the pointer of the voltmeter is exceeding the range of the scale of the voltmeter. Okay, then what happened, you can understand that it is beyond the range. So you have to change that voltmeter, then you can go for the 300 volt range of voltmeter. Okay, then you are again changing. So you are using all those things by using the trial and error method. Okay, so that definitely that is time consuming. If you are going to able these kinds of features for any dedicated experiment, so definitely for changing of all those meter is totally time consuming, and sometimes if that value is too high, okay, maybe you are going to measure the 10 kilovolt and you have some voltmeter 600 volt. You don't know that exact values of 10 kilovolt, because it was initially unknown. Then you are able to connect, you are going to connect the 600 volt voltmeter to the 10 kV system. Then what happened? Your voltmeter will be damaged. Okay, so there will be chances of the damage. Okay, so that's why when you are going to measure any of the electrical quantities, so you have to be very specifically know how much range of the electrical quantity is present over there. That is first thing. Okay, so if you don't know, so you have to go for the automatic instrument. Okay, so that definitely that such kinds of instrument automatically it will be scaled down the all those things. It having some input side is having some step down type of capability things, so that will be directly stepping down all those electrical quantity within the range of the instrument that you are going to be used in automatic system. Okay, then it is able to connect, it is able to then it is able to calculate all those values. So measurement of temperature by a resistance thermometer incorporating a Wheatstone wheel, you can say like that measurement of temperature definitely is an example of the manual measurement. And the other thing that thermometer based incorporating in Wheatstone wheel, definitely all those things will be going as a automatic condition. Okay, so closed loop condition you may say like that. So at all the instant it will calculating all those values. Then the next one is the self-operated and power-operated instrument. Self-operated means what happen? It having some separate or self power supply, so that can operate the entire system. That means entire measuring instrument. Another one is the power-operated instrument. That what is power-operated instrument? That instrument is used the operational power is coming from the circuit. Okay, so it will take directly power from the circuit. So you can say like that it is power operated instrument. Okay, so power operated instrument you can say like that electromechanical instrument that we are normally use like PMMC, like MI type instrument. All the cases the instrument is working only the circuit power or circuit voltage or current is passing through that meter. Okay, so it is power operated instrument. It's an example of a power operated instrument. Another thing is deflection and the null output instrument. Okay, so deflection means that instrument is responsible for deflecting the electrical quantities. Okay, so if the current is passing through that instrument, the deflection will be there. Okay, so pointer deflection. And another one is null output instrument. You know about it. So null output instrument means all the time it will be shows you the zero detection. Okay, so it having some standard EMF sources and it will compare with some another sources. So all the time it is comparing. Okay, so in the result of the comparison is coming zero or the null, you can say like that it is null operated instrument. Okay, if it is not coming null, that means having some of the bias value, some of the positive value or negative value, you can say like that it is not the null operated system, it having some greater value with the standard, or sometimes it is coming negative, so you can say like that it having some lesser value of the standard. So sometimes it is coming positive error, sometimes it is coming negative error. So total 6 number of process are there. You can understand 6 number of classifications. Okay, so you are able to understand. So we can go for next slide. So in next slide, what happen? You can say the basic classifications. Okay, so it is the classifications of the measuring instrument. So presently you can observe that measuring instrument is there. So first one is your absolute measurement. Then another thing is your secondary measurement. So absolute measurement is your basic standard instruments. Okay, so you are using that absolute instrument as a calibrator for the secondary instrument. So again, secondary instrument is segregated into 3 types: so indicating, integrating, and recording. So in measuring instrument also been classified in other manners, that is analog instrument, mechanical instruments, manual instruments, self-operated instruments, deflecting instrument, and the null, definitely analog instrument and digital instrument. The basic thing is measuring instrument. So it having first 2 categories: absolute instrument and secondary instrument. Second category analog instrument and digital instrument. Third category is your mechanical instrument or electrical or electronics instrument. And fourth category is your manual instrument and automatic instrument, then self-operated or the power operated, and finally deflection instrument and the null output instrument. So electromechanical instrument, that my previous slide I told you na, that electromechanical instrument, that thing, the self-operated and power operated. So it's an example of a power operated system. So in case of electromechanical instrument, you can see the basic block diagram. So where one exciter is required. Okay, exciter maybe it is electrical supply. Okay, so it may be driven by auxiliary power or the cell power. Okay, so that is required for what? There is some transducer. In case of transducer, the sum of the source is required. Okay, so sometimes exciter means it may be electrical sources or it may be different sources. Okay, in case of transducer, what happens? It can convert the physical quantity to electrical quantity. So if it is a pressure transducer, definitely exciter means the pressure input is required for the transducer. Sometimes another transducer also be there, like Hall effect transducer. Okay, so or you can say like that LEM type transducer. In that case, some auxiliary power supplies is required for exciting that transducer. So in that case, that auxiliary power supply is required. So mechanical device is there, so it will, the transducer is fetch the data from the mechanical devices, then it will be amplified, and finally it is presenting or recording the data. So you can calculate all those type of data. So input is mechanical, the transducer is converting that value and the measuring that value. After that it is amplified, and finally you are getting that all those type of value. So what are the advantages of the mechanical instrument that I told you? So basic advantages are what? That it is relatively cheaper in cost. Definitely it is cost efficient. Okay, because sophistication is quite lesser in this mechanical device, as well as some you can say like that accuracy, precision. Okay, and reliability. Reliability you may depends, because reliability means how much robust your system is it. Okay, how much reliable your system is it. Reliability also depends upon the aging effect and the moisture and other environmental features. Still you can say like the mechanical instruments are quite reliable, and the range of operation is very high in case of mechanical instruments. So second point is, first one is the cheaper in cost. Second one is that it is more durable, means the working capacity, or the you may use this any very dusty, you can use this very dusty place, sometimes moisture place, sometimes, means because it is cheaper, and sometimes it is in robust in manner. Okay, so it is sometimes in durable. Okay, so there is the provisions of the braking of the instrument is quite less compared to the electrical and the electronics instrument in mechanical instrument. Okay, the simple in design, definitely. Another one is no external power is required, so additional power requirement is not required for mechanical instrument. Third one is reliable and accurate measurement of stable and time invariant quantity. So reliable means it can, you can depends the results of these mechanical devices for a certain durations. Okay, so maybe some of the time range. Okay, maybe some of the application range, that means the how much time is it working over it. Then the accurate, sometimes it also giving you very accurate result. Okay, so for the measuring for the stable and time invariant quantity. What do you mean by that invariant? That means that quantities are not depends upon the time. Okay, so most important disadvantages means poor frequency response. Why it is poor frequency response to transient and dynamic measurement? Okay, so for transient and dynamic measurement means initially how is it operating. Okay, so if you going for the repeated results, then what happened? Mechanical devices having its own inertia. Okay, it having its own inertia. Okay, based on its own inertia, all the time what happened? That input should be overcome this initial inertia or every time. So some of the time what happened, it is not giving you that very good transient response or the dynamic response. So you have to it will give you the best response in steady state, means initial result fetching capability is quite less in mechanical instrument. So these we have to much more focused about the disadvantage. First we are focusing advantage. So next one, the large force requires to overcome the mechanical friction. So first case that for mechanical inertia, then second case is mechanical friction, because all the cases it will be the contact will be there, so there is some problem of the corrosion. Okay, because the mechanical surfaces are involved over here, so all the time you have to giving some of the lubricating oils or lubricating substance all the times to the devices, so that may cause, that may minimize the mechanical friction. Still it is poor, giving you sometimes poor response. So incompatible when the remote induction and the control needed. So sometimes it happen incompatible for any indicating or very remote control means, if you are giving some of the signal from any extreme position to some of the other place, so it will give all the time it is not responding properly. So another big problem is the noise. Okay, noise pollution, so that may call for the corrosive mechanical friction, so that may call for the corrosion, so that may provide some corrosive noise. Okay, so these all are the basic disadvantages for the mechanical instrument. So final one, the advantages of the electrical and electronics instrument. Definitely the non-contact measurements are possible. Another advantage, these instruments consume less power, okay, compared to the mechanical, compact in size. Okay, great flexibility. Great flexibility means any cases you can use any moment. All the time it will give you the more accurate, good transient and steady state performance, good frequency and transient response, remote indications and the recording possible, amplifications. Definitely amplifications produce the greater than the produced and mechanical instruments. So amplification where you can use it for the more gain applications. These all are the basic advantages of the electrical or the electronics instruments. So another definitions, most important thing for the definitions like accuracy. Next one is that precision. Third one is your resolution and the speed of response. So what do you mean by that? Accuracy. So I have already told you that how accurate your response is it, how accurate your measuring devices is it. Means if you are going to calculate, if you are able to measure maximum amount of electrical quantity, so that is written that accuracy determined as the maximum amount by which the result differ from the true value. True value means what? That is your set value, that is your reference value. So how much amount is it varying with the giving some of the response. So maximum amount it should be fetched. That is called the accuracy. Okay. So the true value is not indicated by any measurement system due to loading effect. Due to loading effect means sometimes that instrument also used as a load. It will fetching the power definitely. So some of the loading should be there. So loading effect, lags and mechanical problems. So these three things are specially depends, specially may cause for the barrier of the accuracy. Okay. So accuracy means how much maximum amount of value you can fetch from the system. That is your definition of accuracy. At the presence of loading effect, lags and mechanical problem. Okay. So accuracy of the measure signal depends upon the following factors. So intrinsic accuracy of the instrument itself, accuracy of the observer, variation of the signal to be measured, and the whether it is not quantity is being truly imposed upon by the instrument. Definitely how accurate your system is it. That means if you are going for the very sophisticated application, so you have to think about the accuracy of the instrument. So if you given some of the response to the instrument, definitely how much differ it is coming, how can maximum end, how maximum range it will calculate, or it can able to collect the data. That is your accuracy point. So then another thing is accuracy of the observer. Maybe you are calculating that value, you are taking the reading from your measuring instrument. So there is any kinds of problem has occurred from your side or not, that also be important issue. So how do you take the pointer? So it should be very vertical the pointer should be your eye should be vertical with that pointer, so there will be no any angular displacement with the visions of your instrument pointer. Okay, so there will be no angular displacement, so it always perpendicular or the 90 degree. Okay, so if you are not able to get the value in such a manner, definitely it will differ the position, because if you take some of the angle, vision is there, definitely you can see it is differed with the actual position. So that kinds of accuracy error may be there due to the observer. The variations of the signal to be measured, so very minimal amount of variation is there, definitely it should be measured by the instrument. So that is another that features is also responsible for the accuracy of the measuring instrument. And third point is quantitative measurement. So how much quantitatively measuring possibilities is there in your instrument. Okay, so how much quantitative analysis you are going to do. Okay, that's also important. Then precision. Precision means you are successively measuring the same thing. Okay, so precision means if your measuring device is accurate or the precision is good, then what happens? Repeatedly different frequency means if you are taking the 10 times the result, same thing. So all the time the result should come the exact same value if your precision is good. Okay, so next one is the resolution. Resolution means sometimes your voltmeter is giving 10 volt. Okay, so you are gradually increase that value from 10 volt to 20 volt. Okay, so very small changing of that input, your output should not be changed. Means your pointer should not be differ or should not be vibrate for the very minimal changes of the input. Somehow you are using some variac and that variac is connected to the voltmeter. Okay, so very small deviation you have changed over there. So initially it was 10 volt, then you are giving the 10.1 volt, but your pointer should not be changed the 10.1 volt instantly. If it is permanently changing the 10.1 volt, then it will give you the exact value. Okay, that's the issue. That is called the resolution. Final one is that speed of response. So how fast it is responding. That means how fast it is reached to the set value. That another important issue. So it is called the speed of response. Okay, how fast is it responding? Okay, so if it responding the steady state value very fast, so you can say like that your measuring instrument is very good. But one problem is there. If you accelerate your bike to reach your college very fast, then what happens? There is a tendency for commit the accident. Okay, so very fast response also may cause for unnecessary and overshooting of the system. So unnecessary much more oscillation you can observe by the pointer. That is also not acceptable for a good measuring instrument. So one by one I will come in. Okay, so when I will discuss in PMLC instrument, that will be discussed elaborately. Okay, the speed of response. So normally three types of things are important. So is it critically damped, is it under damped, or it is over damped? Over damped means very slow response. Critically damped means under damped means very fast response, but there is some problem of oscillation. And critically damped means it is not so very fast, not so very slow. So it is critically damped means it is normally critically damped system give you the actual results. Okay, and it is acceptable, globally acceptable. So four important features are responsible for accurate measurement, that is accuracy, precision, then resolution, and final one is the speed of response. Okay, some of the examples are there, you can go through it from your hostel. Okay, if you are not able to understand, so again I will discuss a very simple example based on the deviations, that means full scale deviations of the measuring instruments. Okay, as well as another example for your for your for your based on the error. Okay, now I am going to define you that what are the different types of errors are there. So first you can say like that absolute error. Definitely absolute error means you have to there is some calibrated value, actual value, but the result is different from the actual value. So that is called that absolute error. So delta A means your A means measured value, Okay, so AM means measured value and A is your set value, means absolute value. Okay, so difference between the measured value and absolute value, it is called delta A. Delta A means absolute error. That delta A maybe it is mod value, maybe positive error, sometimes maybe negative error. Okay, so relative error means, again relative means you are going to compare that absolute error with some of the other value, means true value. So true value means it is your measured value. True value means what? Is it your AM, means measured value. So absolute error sometimes is also measured by epsilon 0. So delta A by AM. If you multiply it with 100, so you are getting the percentage. Okay. So percentage error. So three things are there. So one is called absolute error. Next one is the relative error. So formula of the relative error is given over there. And final one is your percentage error. Percentage error is nothing but the making the percentage of the relative error. These three errors are most important. And all the portions of the measurement you have to calculate the absolute error, relative error, and the percentage error. Okay, so absolute error is coming from the measured value minus the actual value or the reference value or the set value. Okay, it may be reverse also. So in that case, the positive error and negative error definition will be changed. Relative error, definitely it's a ratio of absolute error, and the true value means it is your reference value, it is your set value. Okay, and percentage error is you are converting that relative error to the 100% mode. So that is your percentage error. So plus minus, so your actual value A is coming, A is means reference value is coming, reference value or the set value or the actual value is coming, measuring value plus minus absolute error. Okay, so it depends, if the error is too high, then the measured value will be too differ from the actual value. So all the time your main motivation should be like that, to minimize the error. Okay, so if your measuring instrument is so accurate, so all the time it should be minimizing the error. And the limits, that means tolerable limits, how much error should be tolerated in your system, that also important. So it should be in the tolerable range. Okay, if it is in tolerable range, then it is not acceptable, then it is beyond the tolerable range, so it is not acceptable. So all the time you should focus about making it within the tolerable range. Okay, type of different types of error. Another types is gross error, then systematic error. So gross error, then systematic error, and the random error. So what are the gross error? It's error because the mistake by the observer reading. That means that gross error is depends upon the observer. So if we are any mistake at the time of measurement, at the time of measuring the instrument, so we can say like it is gross error. Systematic error, that may comes for the two things. One is responsible for instrumental error, another is called environmental error. Definitely, if that measuring instrument should be placed such a manner that there will be no movement of the air. If any air movement is there, so the result may be differ for the air resistance. Okay, so if it is forward mode, so it may bias the results of the measuring devices. So environmental error may be sometimes responsible. Instrumental error, definitely due to the aging effect. Okay, due to the moisture, the aging effect may be accelerated. That may cause for the instrumental error. So all kinds of things, that means instrumental error, environmental error, normally observed for the mechanical measuring devices. Okay, so random error also be there. That error is variable magnitude and sign do not maintain along the known law. I have already told you that positive error or negative error, you have to find out the standard value. Okay, if you are considered that AM minus A is your measured error minus A is your actual error, so you can say like that error is all the time positive error. So you have to maintain that standard throughout your calculation. If you are considering that A minus A is that residue is coming, that is the negative error, so that should be maintained throughout the calculation. If you interchange, the convention is interchanging different step of the calculation, definitely you will get the erroneous results, erroneous measurements, so that may cause for the random error. So another three error may be observed due to the observer, so that is called the gross error, systematic error, and the random error. So here you can see that the error will occur the measuring result if the proper zero is not setting. So if that pointer is not coming the proper zero, so some of the residue value is there. So you have to changing the scaling. So that pointer should be reach or should be coincide that zero value. Okay. So sometimes that gross error is there due to the pointer is situated in between two of the scale. So definitely the gross error will be there. Okay, that you have to calculate some gross value. Okay, that may cause so parallax error. That is also there. If you are not vertical or the parallel or the perpendicular, your eye is not perpendicular with the pointer, then such type of error may come. So actual reading is there, but you are calculating another two scale. Okay, so adding with the another two scale. So that is called the parallax error. Will occur in the measurement that is pointer is not set in the vertical position. Okay. So these all are the examples of the error, and I have concluded my introductory portions. Okay. So I have now concluded the introductory portions of the measurement. Okay. So if you have any doubt, you may ask me